So general diode is very important topic. Okay. So let us start with first question. So so in first question they have given you general diode. Okay. Battery is given 1 minus 5 volt to 20 volt. Okay. And this is 500 ohm resistance. Okay. This is your xenon diode. And then here 1 kilo ohm resistance is given. Now they are asking, okay, the ratio of maximum power to the minimum power, okay, to the load. So how much is the maximum power can go to the load, okay, and xenon diode voltage is given, okay, breakdown voltage is given 10 volt, okay. So now they're asking what is the maximum power to the minimum power to the load for given battery. What is the P max ratio of P max to P minimum? That ratio we have to find, okay. Now there are two possibilities, okay. When we are using the battery of this range, this diode may be on or this diode may be off, okay. So first thing is you have to find whether this diode is off or diode is on, okay. So if you want to make this diode on, this diode require 10 volt, okay. So first thing is in general diode circuit or any diode circuits, you have to remove this diode and you have to check the what is the open circuit voltage, okay. So you remove this diode and check what is the voltage coming across this load. So if you calculate this load, okay, so you have a 5 volt to 20 volt, okay. So if I use some 5 volt, okay, then obviously the voltage will be less than 10 volt here, yes or no, okay. So if I apply 5 volt battery here, minimum voltage for minimum current here, if I apply 5 volt, okay, so the maximum voltage here can be 10 volts when diode is on. Any question? Okay, so when the diode is on, then the maximum voltage is maximum voltage is here 10 volt, okay. So we'll first find the P minimum, okay. So when this is the 5 volt battery, okay. So let us start this 5 volt battery. With 5 volt battery, how much voltage is coming, okay. So 5 volt battery if I use first, so this will be open, obviously this will be open, this is got 10 volts, so 501 kilo 1500 ohm. So current, how much current is, because here no current is going, I am making this open, so no current is going here, okay. I find total current will be I, and total current will be only equal to IL. This current will go here, so this will be IL, okay. So IL will be what, you have a 5 volt battery, total volt resistance total is 1.5 kilo ohm, okay. I want a voltage across this load which is 1000 ohm, okay, 1000 ohm. So IL will be what, tell me, IL will be what, 5 upon 15, okay, or 50 upon 15, this will be your IL. I have multiplied by resistance also, so this become your VL. This become VL, okay. So this is your VL. VL is how much, tell me, 10 by 3, okay, 10 by 3. So now what is the power here? Somebody's mic is on, please switch off your mic. Now you want the power. Power will be what, voltage V load, okay, VL square upon RL. Now VL square is this is the volt, so this become 10 upon 100 upon 9, okay, volt, and you have to divide by RL. RL is 1000, so this becomes 1000, so this become 100 upon 9, okay, millivolt. Yes or no? Power milliwatt, okay. This will be because power it is by 100 by 9 millivolt. Okay, now when you are using 20 this 20 volt, okay, so when you're using 20 volt, tell me what will the open circuit voltage here if you're using 20 volt. Okay, so V open will be what? V open will be your 20 upon 500. Again, this is 1.5 ohm, 1000 ohm. Okay, this one, and then you have into 1 kilo ohm. 1 kilo means 1000. So this will be what? How much? This will be your 20 upon 1.1 by 5. How much? Tell me. Open circuit voltage is what? Whether open circuit voltage is equal to 10 volt or not? If you're using 20, tell me. If I'm using 20, this is 1.5. Again,
13.33.
13.33, which is greater than 10 volt. Okay. So if it is 13.33, check it one time more. Okay. So then that means now this is greater than VZ. So automatically now this diode will be on, and the voltage here will be restricted to 10 volt. Okay. So whenever the voltage is greater than this open circuit voltage is greater than 10 volt, this diode will become on. So now the voltage VL is 10 volts. Okay, so here VL was this one. So now VL is for next case. If you're using 20 volt battery, that case your VL will be what? 10 volt. Okay, and the P max will be what? P max will be your VL square upon RL. Okay, and this is your 100, and RL is again given 1 kilo ohm. Okay, so this has become your say 100 milliwatt or 100 milliwatt. Okay, and now you want ratio P max to P minimum. So P max to P minimum. Okay, so this is 100 millivolt, and this is 100 by 9 millivolt. So the ratio will be 9. This is the answer. Okay, so if you have doubt, you can ask me. Okay, how we are doing. Okay, so they are asking basically what is the ratio, minimum कितना है, maximum कितना है. So minimum तो obviously है, जब voltage यहाँ minimum होगा, so obviously the current will be here, voltage drop will be minimum. Okay, so minimum there is no issue, and for this minimum voltage, this diode is also off. We can easily say, okay, because this you require 10 volts, this is only 5 volt. So P minimum, you just calculate the current first, okay, and calculate the power VL square by RL. We have calculated first VL and divided by RL. Okay, now second case, this 10 volt. Okay, so 10 volt means whether it is a 20 volt or 18 volt or 14 volt or 15 volt. Okay, here voltage will be always 10 volt. Okay, so you require, if you want diode to become on, you require this 13, this should be greater than 10 volts. So even if you use here 13 volt or 14 volt or 13.33 volt, 14 volt, 15 volt, each case the voltage here will come only 10 volts. Okay, now you know voltage drop here, you know the resistance, you can calculate the power, that is the P max, and we have find the ratio. Okay, अभी कोई डाउट है तो पूछ लो किसी को है तो, otherwise we'll go to the next question. Okay, so shall we move?
Clear, sir.
Clear hai.
Yes, sir.
Okay, let us go to the next question. Next question is very important. So next question, it says a Zener regulator has input voltage in the range 15 to 20 volts. Okay, so again you have a Zener 15 to 20 volts. Okay, and you have given a resistance RS and a Zener which has 6.8 volt. Okay, and you're asking here V naught is given. Okay, so Zener regulator has input voltage range and load current in the range. 5 milliampere to 20 milliampere. Okay, load resistance is not shown here, it's open, shown by open, but the current value is given, so you can understand some load is there here. Okay, and the value of series resistance should be, okay, so this says what is the value of this series resistance. Okay, so there are basically two values of series resistance. One is called minimum value and other is called maximum value. Okay, so because when you apply this battery, okay, there is a minimum to maximum voltage. Okay,
ये कहाँ जानते हो? मैंने कहीं दबा
who is there? किसका mic on है? So if you say, if you're using the minimum here, minimum voltage here, okay, so if you want to make this diode to on, okay, then the current should be greater than IZ minimum. Okay, if the current is greater than IZ max, okay, then what will happen? This diode will burn. So keeping in mind IZ minimum and IZ max, RS has two value. One is called RS max. Okay, this is the worst case condition when here the voltage is minimum, okay, and this voltage is 6.8 volt. Okay,
मैंने कुछ नहीं बोला हैं? किसी का खराब हो ना कोई
Satish, किसका
काम
mic
हो
on है
बेटा
ये?
तो ताकि आता है उसको
Whose mic is on?
वो अच्छी बात
Unnat.
उन्नत कमाई
Okay, so there's two formulas for R first versus RS max. Okay, suppose this is the minimum and you keep on increasing this resistance, so what will happen? The current will keep on decreasing and the one situation will come that here current will be less than ideal minimum. Okay, so this will not work. Okay, now suppose you have a very high voltage and if you keep on decreasing this resistance, so the current will keep on increasing. Okay, and if current will keep on increasing, there is a possibility this diode can burn. Okay, so always this series resistance has a two values, minimum to maximum. Okay, I'm repeating again, this RS should be minimum to max or minimum, two values, minimum and maximum. Maximum value will be what? When you are using minimum voltage. So if you're using minimum voltage, if you keep on increasing the resistance, this current in the resistance will be keep on decreasing, and at particular value of resistance, current becomes so low that this diode will not turn on because the current will become less than IZ minimum. Okay. Now second choice is there, if you're using the high voltage and you keep on decreasing the resistance minimum value, so the current will keep on increasing, and a situation will come where the current here will become greater than IZ max. Okay, so this diode will burn. So first we'll take RS max. So whenever you take RS max, you have to take this V input minimum. This will be V input minimum. Okay, and this is VZ. If you want to make it on. So when you are applying V minimum, this is the RS max. Current will be here IZ minimum. This current will be I the resistance, and I current will be IZ minimum plus IL max. Okay, why I'm taking minimum? Because I'm increasing this one. So if I keep on increasing, this current will, because this will be keeping fixed. Okay, so IZ minimum, if it is the minimum, here it is maximum. Maximum will be IL max. This is one formula, and there's another formula, RS minimum. RS minimum means this should not be go beyond one less value, because then this will burn out. So RS for minimum, this will be maximum. So this will be max, and this is VZ. Okay, and that you will take IZ max, and when you're taking this IZ max, automatically this will be IL minimum. Okay. Now question में क्या है? Question में आपको you have not been given this values. IZ max is not given, so you cannot calculate RS minimum. You can only calculate RS max in this problem. Okay, why? Because if you make this IZ minimum 0, what will become? This will go to upper limit only. Okay, So you can always put IZ equal to 0 or IL minimum equal to 0. Okay. But here IZ max is not given. So we are going to use this value. So I'm only going to find the RS max, and question में option भी दे रखे हैं, RS max के दे रखे हैं. So the RS max will be what? I'm putting this 0. Okay. So this V minimum is 15 volt and VZ is 6.8 and IL max is 20 milliampere. So this become how much? 15. How much will come? 7, 8 point? 8 point how much? 8.2?
8.2.
Okay. And this is 20. This is 1000 go up. Okay. So if you solve this one, this will come 410 ohm. RS max will come 410 ohm. Okay. Now this is the maximum value. Okay. This is the maximum value when I'm putting IZ minimum. But actually IZ minimum is not minimum. This is some value of minimum. So this value will go down. So your resistance should be R should be actually which is required as RS. RS should be less than 410 ohm. Okay. And the only option A says that your resistance is 390 ohm. All other options have a resistance greater than 410 ohm. Okay. So here this is the limit. Okay. Your actual value resistance, if you put this limit, then current will become 0. This will be 0. Nothing will come. Okay. If you want some current to flow here, minimum, at least minimum for current, then RS value should be less than this one, and less than this value is only option A is given. So option A is correct. Okay. So this is the solution of this question. Now we'll go to the next question. Okay. If you are in doubt, please ask. The option A is correct for second question. Okay. Always remember, if you're using your less voltage, okay, then there is a always you should afraid that this current this may not turn on. So this RS has to be some lesser value than some maximum. Okay. Similarly, if you're using higher voltage here, you should always afraid that this should not burn, and this can burn only when this go down. So current will go down. Okay. So that's why this is the RS max, RS minimum. When you use RS max, they should use B minimum here and IZ minimum here. Here, like the formula you should understand. Okay, this is the worst case condition. So maximum here, minimum here, maximum current here, maximum current here, minimum current. That's called worst case condition. Okay. Now the question third is they're asking Zener current. Okay. So Zener पे बहुत क्वेश्चन आते हैं, तो इसको तो अच्छे से करके जाना है आपको एग्जाम में. This is given 40 volts. Okay, V input, and you have here VR plus minus 10 kilo ohm. Okay, and then you have a this Zener diode of 20 volt. Okay, VZ, and you have a resistance here RL of 20 kilo ohm. इसके across you are measuring the voltage VL because this is the load. So IZ पूछा है. Okay, so what is, so you know this is the current IR. Okay, some current will go here and some current will go here. So your IR is always equal to IZ plus IL. Okay. Now कितना IL है, that depends कितना voltage है यहाँ पर. So first of all you have to check whether this diode is on or off. Okay. So always find B open. Okay. So remove Zener diode, and first thing always measure V open. Okay. So I'll measure the V open here, assuming this is not there. So V open will be total voltage, V input, total resistance 10, 30 kilo ohm. Okay, so this V input is 40 volt, total voltage 30 kilo ohm into ion voltage here, B open, this is 20 kilo ohm. Okay, कितना आ रहा बताओ भाई? 80/3 कितना आ रहा है?
26.6.
Something 16 कितना?
26.6.
26.6. Okay, so which is obviously greater than this VZ equals to 20 volt. Okay, so that means now my diode is on. So I have to forget this V open. I have to just remember now once this is on, automatically this is fixed. So my VL is now 20 volts. Okay, so now this greater than 20 volts. So I'm writing my VL is 20 volts. Okay, so now my VL is VL equals to VZ equals to 20 volt. Okay, so Zener diode is on. Zener diode is on. This is equal to 20 volt. Okay, now once I know this voltage, I can find what is IL. IL is nothing, VL upon RL. So this is 20 upon 20 kilo ohm. Okay, so this become 1 milliampere. Okay, now you have to find here, this is on. That means here also voltage is 20 volt. This is 40. So remaining 40 will come here. Remaining 20 volts will come to VR. So you can find total IR. So IR will be what? VR, this voltage upon this R. Okay. So here this is 40. 20 go here. 20 comes here. So this is 20 volt. Divided by resistance is 10 kilo ohm. So this become 2 milliampere. Total current is 2 milliampere. IL is 1 milliampere. So your IZ will be what? IR minus IL, that is 2 minus 1, that is 1 milliampere. And this is the answer. Is that fine?
Yes, sir.
Okay. So let us go to the next question. So question number 4. So you have been given, this is your 35 volt R. Okay. And you have been given 2 Zener diodes connected in series. And you have this RL. Okay. Now what is asking in the question? Question में पूछ रहा है the following Zener diode voltage regulator circuit is used to obtain 20 volt regulated output at a low resistance from a 35 volt battery or supply. Zener diodes are rated as a 5 volt and 10 volt. Okay. The value of resistance R is, so you have to find the value of resistance R. Okay. And the Zener diode voltage here you are getting 20 volt power regulator supply. So this and this is a Zener voltage is 10 volt. So this is 10 volt, 10 volt, total 20 volt you are getting here. And each diode rating is 5 watt. You cannot flow power greater than 5 volt. This is a maximum value. This is a rated value. Okay. So VZ is the rated value of voltage. Okay, there's a Zener voltage and is the 5 watt. Okay, that is the rated value of power. So I can obviously I can find PZ max is given. PZ max is given, that is 5 watt. Okay, 5 watt. So PZ max is nothing. PZ max is your IZ max into VZ, because voltage will be always fixed. only current will change, current will increase. If you remember the Zener diode characteristics, okay, so this voltage will become fixed, but current can go from IZ minimum to IZ max. Okay, so this is given 5 watt. Okay, so your IZ max will be what? 5 upon VZ is 10. How much? Tell me. 1/2. Okay, that is 0.5 watt, or you can say 500 millivolt, 500 milliampere. This is 0.5 ampere. Current is there, ampere. This is 500 milliampere. IZ max value. Okay, or you can do half ampere also. You can put. Now you want to find what is the resistance value, this resistance value. Okay, so if this is 35 volt, okay, and this here you are getting 20 volts, okay, 20 volts, so remaining 15 volt will come here. If this is this diodes are on, okay, so remaining, so you're assuming this is on, then only you can calculate this one. Okay, so the remaining 35, 20, 15 will come here. Okay, so we can find a current IR. So IR will be what? 15 volt divided by R. Okay, IR, and this IR should be greater than at least IZ max. Okay, because this can be equal to or greater than IZ max. This is IR. Okay, should be greater if you're using this maximum condition. Okay, so this IR should be each case this IR should be greater than this one IZ max. Okay, so IZ max plus IL minimum plus IL max. So IL max, so we know only this max. Okay, so we can put this limitation here only. So I can put IR should be greater than IR is what? 15 upon R should be greater than half an ampere. Okay, and this will give me what? R should be greater than equal to 30 ohm. 30 ohm. So the value of resistance should be 30 ohm, greater than equal to 30 ohm. Okay, less than equal to 30 ohm. Less than equal to 30 ohm. So this will go here, this will come here. Okay, 30. So less than equal to 30 ohm. If you go beyond 30 ohm, then what will happen? Okay, so you can just remember this, the answer is 30. Okay, Durvi is there?
Yes, sir.
सही है?
Yes, sir.
चले आगे.
Yes, sir.
Okay,
Hello, sir.
हाँ, tell me.
Why we are taking the IR greater than or equal to IZ max? Why
Because
it is not IZ min?
because you don't know, IZ comes from here only, na. If this is working, this is on, this voltage is on. Now everything depends this IR. Okay, now I'm saying IZ max is flowing here. So obviously, which current is coming from here, that should be greater than IZ max, na? At least equal to or greater than that one. Okay, because some current has to go here also, na?
Yes, sir.
That's why I'm putting greater than.
Okay, sir.
So whenever this R will be some minimum value, okay, then only you can get IZ max only. Okay. The next question is from your, I think, clamper circuits. Okay. So what you have given, they have given you a input voltage, question number 5. They have given you input voltage. Okay. This is plus 2 volt and this is here minus 2 volt. Okay. Let us see this question. And capacitor and diode is given. Okay, a capacitor circuit is there, a capacitor and diode is there. Okay, and this V input is coming onto this circuit. Tell me, what is the name of this circuit? Okay, tell me. I told you different type of clampers. Shift down, shift many clampers, at least 4 to 5 to 6 clampers we have discussed. Okay, now this is V input. Okay, and you want to measure what? V output. Yes or no? Question में क्या पूछा है? Tell me. Question में क्या पूछा है? Question में पूछा है waveform. You want a exactly correct waveform of V naught. Okay, so you are measuring basically V naught here, and you want the correct. This is the input waveform, and you want the output waveform. Okay, so let us do it this one. Okay, so this is a clamper circuit. I told you always. First, you have to check in clamper circuit that current. What is the current direction? How current can flow? In that direction only this capacitor will charge. So it's not necessary. So you suppose you have circuit, okay, and you're giving this input, and this lead is going to the CRO. So immediately in front of you, you will get the output waveform. Okay, you'll get input waveform, you will get the output waveform. Okay, so it's not necessary. First positive cycle is coming up, first negative cycle will come. Okay, that you should not worry. Okay, you should worry how can this capacitor charge. Okay, so there's nothing like a t is equal to 0. Because whenever you have a circuit, you give the input and you check the output, automatically waveform will come to in front of you. Okay, that happens everything within microseconds. Okay, so you will get a stable waveform. So there's nothing like a t is equal to 0. So you always have to see how this circuit works. Okay, so always try to see how capacitor will charge, and if it is idle diode, okay, it will not consume any voltage. Okay, it will not take even 0.7 voltage. If it is a silicon voltage, it will take 0.7 voltage in this direction, but now this will be replaced by a short circuit. Okay, if your current is flowing, if a negative cycle, this will charge here and this will charge this one up to the max V max voltage, which is 2 volt, because here is the square wave. So automatically this will get charged up to maximum value up to 2 volts. Okay, and this itself is a 2 volts. Okay, so this is 2 volt. Now this is V input. Now once this is a 2 volt, this voltage is always greater than this input voltage, because or at least equal to this voltage. This is also 2 volt, this is also 2 volt. Okay, this battery is going like this in positive cycle. So what will happen whenever this capacitor get fully charged? Now rest of the time period, this diode will become open, because now this cannot be get forward bias, because this voltage and this voltage are equal. Even if it is sine wave is there here and it's the V max is there, so V max will be always greater than this one. Okay, so for even the negative cycle, the diode will be a reverse bias. For positive cycle, this is obviously reverse bias. Okay, how was the diode? You see, your diode was like this. So if you even to see positive cycle, this battery is already making a reverse bias. This is also making reverse bias. Now it is plus, minus, plus is already reverse bias. Okay, but even in the forward bias, when we charge this one, once this is charged, this will balance, this voltage will balance this voltage. If this is going in reverse bias, now is negative cycle, current is going like this will balance this one. So this diode will be always open circuit. Now open circuit voltage. Now assuming this is open circuit reverse bias, you have to calculate the V output waveform. Okay, so now let me write the equation. Okay, this is my V input. So my V input, Kirchhoff law, minus V input minus VC. Okay, let me say this is a VC. Okay, capacitor voltage, which is of course equal to VM. VM. Okay, VM is up to 2 volts. Okay, maximum voltage to charge, or say this is 2 volt. Okay, minus VC, and I'm measuring the voltage here, plus minus. This is V naught equals to 0. This voltage, this voltage, this voltage. Okay, so my V naught is VI plus VC. Okay, now let us see for positive cycle. For positive cycle, my Vi is positive. Okay, this direction only. So V naught will be 2 volt, and this is always how much? कितना आएगा ये क्या आ जाएगा? 0 volt आ जाएगा, क्या आ जाएगा? Just check. So this will be your 1 minute. So this is Vi plus Vc for positive cycle. Okay, so if it is getting charge here, so Vc is also 2. Here I'm putting 2 volt only. If I'm putting minus also, okay, and this value is 2 volt only, so this become 2 volt, so this become 4 volt, total 4 volt. Minus I already put here, so 2 times you cannot put minus. Okay, minus I already said this is minus Vc. Now only you have to put the magnitude, so this is the 4 volt. Okay, and for negative cycle, what will become? I assuming this way, negative cycle, what will become? This become plus, this become minus. So this will reverse. So this will become now minus 2 volt. Okay, minus 2 volt, and Vc is always remain like this only. Okay, so I have already put a sign here. This will be 2 volts. So this comes 0 volt. Okay, so either you can write for different cycles. Okay, you can write separately a positive cycle. This equation is correct. Minus Vi minus Vc plus V naught. V naught is as well. Vi is 2, Vc is 4. Okay, for negative cycle, what will do? You will change this sign. This will keep fixed. Okay, voltage always you measuring like same way. So only you have to shift this one. Okay, so I have reversed the sign of V input now, because V input will become like this. So plus here plus Vi will come for negative cycle. So I have written the equation, and the later I will change. You can do in any other way. So basically this is your values, and now let me draw the output waveform. Positive cycle, it is 4 volt, and this is 0 volts. Okay, so let us see how it is getting shipped. So this is, if you check this one here, this will become 4 volt, and negative cycle will become 0 volt. Okay, so basically this is your waveform, output waveform V naught. Okay, so this is basically this is the positive clamping. Okay, and your signal will always get clamped in the direction of the current. You always remember. Okay, if you get confused earlier, this was my diode, and this is my current direction. So obviously my signal will go up. If my current direction is like this, my signal will go down. You check all the cases what we have done in the class. Okay, it will always follow the current direction current. So now current going up, the signal will go up. Okay, that you remember. Is that clear? This clamping is very important. Zener diode clamping. Okay, for your course. Shall we move to the next question?
Yes, sir.
So now everything is simple. Question number 6. Okay. Question number 6 is this is V input. This one. This is 3 volt. This is 1 kilo ohm. And this is your V out. And here I'm applying some V input. Okay. Some V input, which is what? Let us say sine wave. Okay. A sine wave of amplitude is applied at the input. Okay, so your input wave is sine wave, and you want to measure some output waveform. Okay, so input is coming sine as a sine wave. Okay, so this is the input, and this is a 3 volt here. What is the amplitude of V input? Tell me. What is the amplitude? Amplitude is given in the question or not? Tell me. Question में क्या दे रखा है? Omega. Is that given? Amplitude is given in the question.
नो सर, बस बोला है कि साइन वेव है एक
Sine,
सिंपल एम्पलीट्यूड का।
sine wave basically amplitude दे रखा है. Okay. So हम क्या करेंगे? हम मानते हैं इसका amplitude is Vm. Okay. Now this, if your V input, okay, this is V input. If your V input is less than 3 volt, then this diode will be reverse bias. If V input, if this voltage is less than this volt, positive, negative, okay, this diode will be reverse bias. So diode, I said diode D is off. Off का मतलब क्या है? No current will flow. Okay. In that case, what will happen? Tell me, what is your V output? So in that case, if no current is flowing here, this is open. Okay. So no voltage drop here. So voltage drop is not here. So whatever, no current is flowing here, circuit in the circuit. So here also voltage drop is not there. So whatever voltage is here automatically come down to here because there's no drop. Okay, this is voltage. Now current is not flowing. So no drop here. And this voltage will be automatically equal to V input. So your V output will be equal to V input. Okay, whenever it is less than 3 volt. Okay, and if Vn input becomes greater than 3 volt, then your V naught will be what? Tell me. If V input is greater than 3 volt, this diode will be what? This diode will be your
Diode get on.
And this is the silicon diode. Check it.
So 3.3
0.7, okay, 0.7. If this is silicon diode, you can assume this is silicon diode. So question में जैसे दे रखा है उससे तो लग रहा है silicon diode है. So that will become your 0.7 volt because once this become on, you can always replace this by a battery of 0.7 volt. So this becomes 0.7 volt. Okay, and if you see the reverse cycle, negative cycle, okay, negative cycle is already reverse bias. If you were negative cycle, it will be always off. So in this I'm talking about positive cycle. For positive cycle, okay, you have to see these two cases. And negative cycle because this is always off. So your V output will be always equal to your V input. Okay, whatever is coming, negative will come. Okay, always equal to V input. Okay, so let us draw now the waveform. So waveform, this is my coming input. Okay, and my output will be, I have to see, this is my Vm. I say, let us say this is 3 volt. So until 3 volt, okay, your V output will be like same because this is off, diode is off, no current is flowing. No current is flowing, matlab up to here. Okay, this will be like this, and then this will go to, that will be fixed up to 0.7, and then again this will come like this. Okay, here up to here. This portion will be clipped. Okay, because for this portion, okay, this is excess of 3 volt. For this portion, this is on. So for this portion, you get only 0.7 volt. Up to here, you get same thing here. Okay. Oh,
Sir,
sorry.
output is
No.
0.7.
Wait. This 3 volt. This is not 3 on this 3 volt. Because what will happen once this become on, okay, and if this is on, you can replace by short circuit because the silicon voltage value is not given, and this is 3 volt is also given. So this 3 volt will come here. Are you getting? If this
Yes,
is short,
sir.
this is short, then this 3 volt is automatically here. So this is go to 3 volt. Okay, up to here it will clip. Okay, and for negative cycle you get exactly this will follow your V input. V output will be exactly equal to V input. So you'll get this one. Okay, so what is the option? Tell me, which is you saying this one?
C option.
C option.
D, sir.
D. Okay, so this is D option. आंसर में चेक कर लेना, डी ऑप्शन ही होगा.
Yes, sir. D है.
Now let us say question number 7 भी एग्जैक्टली ऐसा ही है। 7 में कुछ ज्यादा कुछ नया है नहीं। ओके, सेम इसी तरह का क्वेश्चन ही है। अगर ये डायोड जो होता, अगर सिलिकॉन होता, then this will be 0.7 and this will be 3 volt. Okay, so this is your this is 3 volt battery like this. So this voltage will be 3.7 volt. Okay, you have to keep in mind. Next question. Next question आप करो, exactly ऐसा ही है, and tell me the answer. Identical silicon diodes दे रखे हैं. Okay, the input AC voltage waveform has the peak value VP equals to 2 volt. 2 volt का दे रखा है और आपको दो डायोड दे रखे. This is your V input. Okay, AC volts है. AC V input. This is R. This is diode. Okay, और ये डायोड ऐसे दे रखा है. And this is a resistance R is given. You are measuring the voltage across P and Q. Okay, you can call V naught, V output or VPQ. You are measuring waveform. Okay, and the input waveform is sine wave. Sine wave of 2 volts. Okay, so let us check very simple question. Okay, so ये तो हमने करा है क्लास में. Only the here extra thing is they are done with put an R. Okay, so let us see. So basically this input is coming, this is your input is coming 2 volt. So this is a positive cycle, this is a negative cycle. So for positive cycle, this diode is on and this is off. Yes or no? So when this is
Yes, sir.
on, so if it is on, this becomes 0.7 and this is become off. This is reverse bias. So no current will be flowing here. So your V naught will come what? So you have to check first whether before coming to 2 volt, your V input should be greater than 0.7 volt. Then only this will be on. Okay. So for positive cycle, if my V input is greater than 0.7 volt, my V output will be 0.7 volt. Okay. If my V input is less than 0.7 volt, then my VPQ will be equal to V. What? This is off. This is off. If this voltage is less than 0.7, if this voltage is less than 0.7 volt, okay, even this diode will not turn on. This is already reverse bias for all values. Even this will not turn on. This is also off. So if this is off, no current here, no current here, no branch here, no current is flowing here. Okay, so automatically the voltage, whatever coming here, it will come directly here because this is also open here, no current is flowing here, circuit is not closed. So this voltage will automatically come here. Okay, so you can get for positive cycle, you can get initially you get exactly like V input, and then it will be like this 0.7 volt. Okay, now let us see for negative cycle what happens. Negative cycle, this is on this, so this is always, even negative cycle, this is always reverse bias. Okay, whether the value is less than 0.7 or greater than 7 volt. Okay, so for negative cycle, the voltage is coming like this. So this is always reverse bias. So this is open, and this is what? This is your, this is like this. Sorry, this is like this positive cycle. This is my like this. Okay. So now negative cycle, negative. This can become positive. Okay, this diode can become positive, and the condition is there again, the magnitude of this one should be greater than 0.7. Okay, so if it is less than 0.7, okay, this will not turn on because this even in this direction this requires 0.7 volt. Okay, if I have to replace this by a battery, I can assume my current is coming like this now. So this has to be also in magnitude. Direction is reverse, but magnitude has to be greater than 0.7 volts. So initially it will go as it is like this, as it is like this, okay? And once it is on, you can replace this by a battery of 0.7 volt, and some current is flowing here, IR. So now if you measure this V naught, again V naught is opposite, so I'm plotting opposite only, okay? I'll measure VPQ always like this only, but now current is coming in this direction, so this voltage is like this, okay, and this voltage is like this. So my VPQ will be what? I'm measuring like this, opposite, minus IR and minus 0.7 volt total. That is minus IR plus 0.7 volt. Okay. So now this IR fraction will add. So here this is 0.7 and this is as it is. But now here it will go a little bit higher because IR contribution also there. So this will go like this and like this, okay. So magnitude will be somewhat here 0.7 clipped, here somewhat more, okay. So this will be your like this, this one, okay. This dark portion will be your V output. I should have put a different color, okay. So tell me, what is the option? Which option is correct? So option C is correct.
Yes, sir.
Okay. So option C.
Yes, sir.
Okay. Option C is correct. So अभी clear है कि नहीं है? Okay. So let us say question number 8 now. आप आउटपुट हमेशा ऐसे ही मेजर कर रहे हो, ओके? तभी तो नेगेटिव पॉजिटिव तभी तो इसको नेगेटिव ड्रॉ कर रहे हो, ये आपका आउटपुट है, ओके? तो ऑलवेज थोड़ा सा मैथमेटिक्स और आप जो कर रहे हो माइंड में, वो दोनों में सिंक्रोनाइज होना चाहिए, एग्जैक्टली क्या कर रहे हो, ओके? And let us question number 8. So question number 8 क्या है? Question number 8 में आपको एक AC सोर्स दे दिया है, उसका VRMS आपको दे दिया है 24 वोल्ट, okay? They put on capacitor here. This is diode here, okay? And this is diode here, and these are all ideal diodes. This is C and this is R, okay? So basically, if you see carefully, this is your doubler circuit. Okay, we have done the voltage multiplier circuits. So this is the question of doubler circuit. Okay. So doubler circuit का मतलब क्या है? आपका V output जहाँ पे जो measure करोगे, that will be twice of peak value of your input voltage, that is 2 Vm. Okay, let us see how. Okay. So always this is like a clamping circuit. You have to see first this branch, this loop. This will get charged. This can charge only through this one. So this will charge up to the peak value of Vm here. Okay. So the VRMS given, VRMS Vm will be what? Okay. √2 into VRMS. Okay. So you have to multiply this by √2. Okay. That is Vm. So this capacitor will charge up to here. And once this is charged in this loop, this is the max voltage compared to this one. So this will be always off. Okay. And now if you see this again, if current flows, okay, next time what will happen? Now this is source, okay, and what will happen? Negative cycle, no, So okay. So now if you want to charge this one, now this capacitor will charge. This capacitor will get charged up to how much? Tell me. कितने voltage तक होगा? I want to know what is the VC here. So I'll apply condition here. So I have minus, this will be max voltage V input or V max. This is also minus V max, and this is my plus VC in this loop. This voltage, and this will become on. Okay. And if this become on, then this will be your VC equals to 0 and VC will be equals to 2 VM. Okay. So here the voltage will come 2 VM. Okay. That's why this is the voltage doubler circuit. And so voltage output will be VC, V output will be equal to VC equals to 2 VM, and 2 VM is 2 under root 2 VRMS. Okay, so 2 into 2 root 2 into 24 volt, and it will come around 68 volts. Multiply, it will come around 68 volts. Okay.
Yes, sir.
You have to see direction here, whether there's charge here like this or like this. You have to check that one. Okay. So I think this is the greater, so this will charge like this only. So क्वेश्चन सारे एक जैसे आ रहे हैं, आपको बस क्लिपिंग एंड क्लैंपिंग क्लियर होना चाहिए और जीनो डायोड होना चाहिए. इसी पे सारे क्वेश्चंस आ रहे हैं आपके इतने सालों में. नेक्स्ट क्वेश्चन अगेन आपका जीनो डायोड का है. Okay. So you given minimum and they're asking minimum and maximum values of input voltage. Okay. So you are given, this is my V input. Okay. Resistance value is given 125 ohm. Okay. And here Gina diode is given. Gina diode कितना है? 9 volt. Okay. And RL also given. RL is given 470 ohm. Okay. And IZ max का वैल्यू दे दिया है. Okay, that is good. IZ max दे दिया है. कितना दे दिया है? IZ max दे दिया है आपको, is given 65 milliampere. Okay, very good. So just आपको क्या करना है? They asking what should be the value of V minimum. This diode should be on, but the value should be this is the range. They asking what is the range minimum V input minimum to V input max. V input minimum to V input max. What is the range of this battery power supply? So if you want to make this open conduct, the voltage, of course, this should be equal to at least 9 volt. Okay. So V open. So if you want to have minimum value, so V open. So for minimum value, this power supply should be such that it should at least give 9 volt here. So your V open should be at least equal to VZ, which is equal to 9 volt. Okay. And V open is what? V open is your V minimum upon 120 and 470. कितना आएगा? 120 and 470. Tell me. 570. 595. Yes or no?
Yes, sir.
ये ओम है. ओके. तो कितना आएगा? V का मिनिमम का वैल्यू कितना आएगा बताओ?
Sir, what are 11.39 volts?
So V open, okay, and here 470 should be there also. 470 should be also there. Okay. So my VI minimum will be 9 into 595 upon 470. कितना आ रहा है?
Sir, 11.39 volt.
11.39.
Yes, sir.
बाकी लोग भी चेक करो. I don't have a calculator, so I cannot do it. Okay. So this is the
Yes, sir.
this is saying there's a minimum value, and max value should be like this because this is a fixed, and this is the mix. This is the max value should not be such that this should burn. This should not burn. If it is get burned, now this is a 9 volt. So if voltage here is fixed, so IL is also fixed here. This current is also fixed here. Now if you keep on increasing this one, this current will keep on increasing. This current will increase. This current is fixed. So whatever extra current is going to be here, and this also should not go to the IZ max. So VI max, always remember, I'm repeating again. Once this is resistance is fixed, this current is fixed. This voltage minimum, this is on. You're getting fixed current here. Still you're increasing this one. This voltage is fixed, this voltage is fixed, this current is fixed. If you're increasing this voltage, only this voltage is going to increase. If this voltage is going to increase, this current is going to increase, and this current is going to increase. This current is fixed, so this current is going to increase. Okay, so while getting VI max, you have to keep on mind IZ max. Okay, so now I want to calculate VI max. So VI max will be what? VI for that, there is a limit of IR max because resistance is fixed, so current only can be max into resistance R, and this voltage is always fixed. I am putting this in 9 volt. Okay, now R is fixed. IR max is what? IR max is your IZ max, and IL is always fixed. So this IR will be this one. Okay, IZ max is 65 milliampere plus IL is how much? IL you can calculate. Here 9 volt is there, 9 upon 470. Okay, 3, how much coming? Tell me. How much current is coming? 9 upon 470. What is the current value?
19 milliampere.
Okay, 19 milliampere.
19.1.
19.1.
9151 volt sir.
हाँ, जो भी तुम कर लो, और यहाँ पे ये आ जाएगा 19.1 मिली एम्पियर. इसको ऐड कर दो इसके अंदर, तो ये कितना हो जाएगा बताओ? 75 85 ना. मैं इसको 19 मानता हूँ, तो ये 84 मिली एम्पियर ले लेता हूँ अप्रोक्सीमेटली. You just calculate. Okay, so this is your 84 point something into R is 125 and plus 9. Tell me the answer. VI max कितना है?
सर वीडियो स्टक. हाँ ठीक है, वीडियो स्टक हो गया था.
अच्छा, कितना आ रहा है बताओ?
दोनों को जोड़ने पे 84 मिलियम्पियर होगा.
19.51 volt sir total.
कितना आ रहा है? कितना आ रहा है? 19.5.
19.51.
19.5 वोल्ट है टोटल ना. 9 प्लस ये, हाँ 19.5 आ रहा है. ठीक है, तो तुम्हारा आंसर क्या हो जाएगा? डी हो जाएगा ना.
Yes, option D.
ठीक है, चेक कर लो आ रहा कि नहीं आ रहा है. Now see question number 10. So ये सर्किट का वर्किंग should be very clear and it's very easy. सारे क्वेश्चन इसी पे आ रहे हैं. If you understand the working of this zener diode, अब कैसे भी क्वेश्चन पूछ ले, you can understand. Okay, so you should इस पे पहले काम करना है सर्किट के बेसिक्स पे. ओके, क्वेश्चन नंबर 10. क्वेश्चन फिर क्लिपिंग का ही है. ओके, so for the following circuit, choose the correct waveform corresponding to the output signal given. V input दे रखा है आपको, पाई साइन वेव दे रखा है. सर्किट नहीं दे रखा क्वेश्चन में. क्या व्हाट इज सर्किट? सर्किट कट हो गया क्या? सर्किट क्वेश्चन.
सर मैं ग्रुप पे दे दूं?
हाँ दे दो. सर्किट देख लेते हैं, फिर उसके बाद में करते हैं इसको.
सर भेज दिया।
कौन से ग्रुप पे भेजा है? नहीं अभी तो मेरे पास नहीं है। कौन सा वाले ग्रुप में भेजा है? क्रैश कोर्स में? किस में भेजा है? हाँ आया। तो हम
आ गया सर।
हाँ आ गया, ठीक है। सो ये क्वेश्चन दे रखा है आपको, V input, okay, and this is R, this is a battery, and this is a minus, this is 3 volt, okay, and this is grounded, okay, and this is a xenon diode. This is xenon diode. और आपको V output पूछा है. What is V output? Okay. So this silicon diode, it is given silicon diode. Now let us see the question back. तो क्वेश्चन में बोला है साइन वेव है and forward bias voltage of diode and zener both are 7 and reverse is 3 volt. Okay, so this reverse is 3 volt, and if it is forward it is 0.7 for both. That is become easy, question become very easy, because zener always works like an ordinary diode in forward bias. Now you have been given input which has a which is 5 sin omega t. Okay, maximum voltage is 5, so amplitude is 5. This is your input wave, maximum is 5. Okay, let us discuss. Now if I want to make this diode on, okay, how much voltage I require? Tell me. If I want to make this diode
3.7
3.7, because ये तो 3 वोल्ट, this is already reversed by 3 वोल्ट, ये सिलिकॉन है, तो मुझे इसको 3.7 वोल्ट चलाना पड़ेगा करंट फ्लो करने के लिए. ओके, और जो कि इसको फ्लो कराने के लिए कितना चाहिए मुझे वोल्टेज? 3 वोल्ट ओनली, बिकॉज अगर इसको कनेक्ट करना है, जीनर डायोड तो रिवर्स में कनेक्ट करता है ना, दैट इज द एडवांटेज. रिवर्स जीनर डायोड कंडक्ट्स इन द रिवर्स डायरेक्शन, सो आई ओनली रिक्वायर 3 volts. So whenever two diode circuits are in parallel, you have to see which branch will get open first. तो ये इसको कम वोल्टेज चाहिए तो ये ऑन हो जाएगा, तो ये पॉजिटिव में ये ऑफ ही रहेगा. तो यहाँ पे जो वोल्टेज आएगा मैक्सिमम 3 वोल्ट ही आएगा, क्योंकि ये ऑन हो जाएगा, करंट शुरू हो जाएगा यहाँ से पहले, इसकी जरूरत ही नहीं है. सो initially what will happen? Initially up to 3 volt you won't get anything, because neither this is on, now this is on. So whatever input this is off, open, this is open, because this is reverse bias. Voltage is less than 3 volt. Whatever voltage you're applying directly coming here, so up to 3 volt you get as it is, and then it will go, then it will plug here, up to here it will be same, and then it will be clipped here up to 3 volts. Okay, it's 3 volt, and when you come down again you get same thing here. Now you have to see in the reverse direction. Okay, if you're coming here, so this diode is reverse bias, you are further making it reverse bias, so ये तो connect करेगा नहीं. Yes or no? If this diode is already reverse bias, पहले से reverse bias है this battery. Now you again negative cycle, you coming, current is coming like this become also plus, so this and this will add, this making further reverse bias, but this can make this is a forward bias. So once this become forward bias, this will come like this, 0.7 volt. Okay, so V output will be minus 0.7. That means, so before, if this is less than 0.7, तो कोई करंट फ्लो करेगा नहीं, ओपन है तो एज इट इज आएगा. अप टू हियर दिस इज एज इट इज. ओके, सो नाउ बेसिकली दिस इज योर सर्किट, दिस इज योर आउटपुट. सो अप टू हियर when it is less than 0.7, okay, negative voltage come to here, V output will come like this here, and then it will clip to 0.7 only here, and then it will come here. So dark portion is your output wave. Okay, so this is your output wave. कौन सा ऑप्शन है ये?
ए, ऑप्शन ए.
ऑप्शन ए सर.
ये ऑप्शन ए होगा. ओके, आई होप दिस क्वेश्चन इज क्लियर. सो क्लिपिंग क्लैपिंग के क्वेश्चन बड़े आसान होते हैं, ठीक है, अभी जैसे हमने किया, कितना आसान क्वेश्चन है. थोड़ा सा बस आपको अवेयर रहना है, गलती नहीं करनी है। क्वेश्चन फटाफट सही हो जाएगा। और कॉन्फिडेंट रहना है। इलेक्ट्रॉनिक का सर्किट बस आपको कॉन्फिडेंट रहना कि मुझे आता है, ऐसा कर एग्जाम में करके आना है, ऐसा नहीं है थोड़ा सा कुछ अलग से दिख जाए तो मेरे से होगा नहीं, हाथ पैर नहीं चलाओ। ओके, यू टू अटेम्प्ट द क्वेश्चन, अटेम्प्ट करते हो जाएगा, क्वेश्चन हो जाएगा बड़ी इजीली से। सो सबसे पहले करेज जरूरी है, अटेम्प्ट करना जरूरी है। ओके, देन क्वेश्चन नंबर 11, question 11 is a diode at room temperature KT is given 25 millivolt with a current of 1 microampere has forward bias voltage for, तो बेसिकली डायोड करंट पूछा है आपको। ओके, डायोड करंट क्या होता है, फॉरवर्ड करंट पूछा है। इट विल बी दैट इज इक्वल टू आई डॉट एक्सपोनेंशियल, ओके,
VT minus 1.
क्यू वी के टी -1। यहाँ पे फैक्टर भी होता है, आइडियलिटी फैक्टर भी होता है, अगर क्वेश्चन में दे रखा है तो ठीक है, वरना इसको 1 ले लेना आपको, ठीक है। एंड so this current is they are asking in the question, and forward voltage is given. Okay, so now say first time current is IFN, second time current is say IF2, I0, this is V1, say this is exponential Q V2 KT -1, okay, and this KT by Q thermal voltage. Okay, this KT by Q is thermal voltage, KT by Q is thermal voltage, and this value is given already 25 millivolt. So you just have to put the values and you have to solve this one. This is given KT is KT is 25 electron volt. Then you can solve this one. Electron voltage, okay, charge. So just solve it. You want IF2, IF1 will be equal to what? Exponential. Okay, this voltage is given 0.5 volt, and just you solve this one. KT by Q, you solve this one -1, and exponential कितना दे रखा है V1, V1 is given
0.4, sir.
0.4, so 0.4 KT upon Q -1. Okay, if you want you can neglect 1 because this is a 5 volt, this will come something in millivolts. Okay, this will always come in millivolts, so if you want you can neglect this one also. Okay, if you neglect this one nothing will happen, and you IFN is given, you can find IF2. बताओ कितना आ रहा है, multiply this with IFN, IFN सॉल्व करो बताओ। और IFN की वैल्यू आपको दे रखी है 1 माइक्रो एम्पियर, so IF1 is given 1 माइक्रो एम्पियर। दिस इज डायोड इक्वेशन, इसको शॉकले इक्वेशन भी बोलते हैं। कितना आ रहा है, एक्सपोनेंशियल निकाल के देखो।
Sir, इसका आ रहा है 54.5 माइक्रो एम्पियर.
ओके, तुम चेक कर लेना आंसर में, ठीक है, मिला के फॉर्मूला यही है। ओके, ना अब ये जो क्वेश्चन 12 है वो सेम है जो अभी हमने किया था, जीना डायोडल क्वेश्चन और डायोडल क्वेश्चन। क्वेश्चन नंबर 12, क्वेश्चन नंबर 12 में क्या है, okay, you have been given diode, two diodes, one is 0.7, other is 0.3 volt cutoff voltage, and connected to 10-volt battery, and then you have a resistance here, and R is your 100 kilo ohm, 100 kilo ohm, and they are saying the diode IV characteristics is like this. That means voltage across the diode is fixed. Okay. So now 2 are series. You want to find the current R in microampere. तो जब भी ये कम वोल्टेज पैरेलल में है, कम वोल्टेज वाला पहले ऑन हो जाएगा, तो ये ऑन होगा ही नहीं, ये ऑफ ही रहेगा हमेशा. ओके, तो आपका ये सर्किट बन जाएगा. दिस इज प्लस माइनस 0.3 वोल्ट. दिस विल बी ऑलवेज ओपन बिकॉज ये वोल्टेज हमेशा कम रहेगा, इसको ऑन करेगा नहीं. सो यू कैन राइट -10 प्लस 0.3 वोल्ट प्लस I इंटू आर इक्वल्स टू 0. ओके, तो आपका जो I आएगा दैट विल बी 10 माइनस 0.3 अपॉन 100 किलो ओम, एंड दिस इज व्हाट, दिस इज 9.7. ओके, 9.7, एंड अगर इसको 10⁵5, ओके, सो दिस इज 97 माइक्रो एम्पियर आएगा आंसर. चेक करो आंसर आ रहा है कि नहीं आ रहा है. ओके,
Yes, sir.
चलो चलो ब्रेक है अभी. विल मीट अगेन. हाउ मच? 6 अराउंड 6:45 6:40. कितने बजे आना है बताओ? कितना ब्रेक चाहिए? 10 मिनट का, 15 मिनट का?
Sir, 10 minutes.
So I will come out around 7:20 हुआ है अभी मेरे वॉच में. 7:20 7:35 पे आते हैं. ठीक है, 5:35 पे आते हैं. ठीक है,
Okay, sir.
15 मिनट का ब्रेक. चाय वाय पी लो तुम लोग भी, इवनिंग टी. It is not resuming. Okay. So if I was telling, if you have different section of material have a different Fermi level. Okay, and when you align them, then one material should have a single Fermi level. If the Fermi level is not single, then always charge will be keep on flowing. Okay, that's why I give example. If you have bar, if you apply voltage, there is no current initially. If you apply voltage, that means you are shifting the Fermi levels of two ends. Okay, and that makes the current to flow. So similarly here, these have different Fermi levels, but when you make joint, okay, their entire this section should have a single Fermi level. Let us first see the n-type material. So n-type material, this is your conduction band, and this is your valence band. Okay, and this n-type material has a Fermi level always here, close to the conduction band. And then you have a p-type material. This is your p-type material. Okay, which EC, EV. Okay, I'm assuming the band gap is same almost. Okay, and this is P Fermi level will be always here. Fermi level will be here. Okay, now again if I take N, so N will be like this, and this will be a Fermi level. Okay, again this is the EC, top of conduction band, VC. Okay, now you want to join this material. Okay, so if you join this material, what will happen? The electron will flow from higher level to lower Fermi level. So electron will always flow like this. So if electron flow like this, here the concentration of electron is decreasing. Okay, so this Fermi level will go down, this Fermi level will go up, because here now these electrons are coming and combining with holes in p-type material. So hole will decrease. Hole will decrease means now it is not this, the p-type nature is reducing. Here n-type nature is reducing. Intrinsic means Fermi level is at the middle. So when the electron is here, this is n-type, top of the close to the conduction band. Okay, metal is inside. So it's close to the conduction band. It is a nature is n-type. Close to the conduction band, the nature is p-type. If you decreasing the number of electrons from here, it will go. This will go down. It will go towards middle part, which is the characteristics of intrinsic semiconductor. So what will happen if this go down and this go up? Okay, so the Fermi level will what, like this. this band will also decrease. Okay, because gap cannot decrease. Okay, this gap cannot decrease, so there will be like this one. Okay, similarly here what will happen? Again here same thing will happen. This will come down. Okay, and this will go, this electron transfer will take place here. This will come like this. Okay, so check the option. This should be the correct option. Check the option.
Option B, sir.
तो ये सर ऐसा ही है, चेक करो एक बार. ऑप्शन बी आ रहा है क्या कि सी आ रहा है?
B है option.
बी आ रहा है
सर.
Just
B
one
आ रहा है
minute.
sir.
Then let me check. Okay, so हम क्या कर रहे हैं, हमारा ऊपर कौन जा रहा है? Okay, अच्छा ये ऊपर जा रहा है ना, हम उल्टा प्लॉट कर रहे हैं ना. Just 1 minute. Okay, assuming these are the conduction bands. Okay, so ये नीचे जा रहा है ना, बेसिकली ये नीचे जा रहा है, हमने उल्टा कर दिया ना. ये नीचे जा रहा है तो गैप तो ये नीचे जा रहा है तो गैप तो सेम ही रहेगा. ये नीचे जा रहा है तो ये फिर इसको ऊपर जा रहा है ना, तो ऐसे आएगा, ये ऐसा आएगा. This is like this. ये ऐसा आएगा. Okay, and Fermi level will be like this, middle of this one. क्योंकि हम PNP जब हम PN junction ड्रॉ करते हैं, we draw PN junction like this. Do you remember PN junction? This
Yes, sir.
This is P part, this is N part. Okay, so we always draw like this. So NPN we will draw like this. NP we will draw like this. Okay, and again this is PN. So PN means again like this. So like this, that you have to remember. So this B option is correct. अभी किसी को डाउट है तो shall I clear more or is okay? Tell me.
Clear, sir.
Clear. This you always remember is PN. PN is like this. Okay. So NP will be like this, opposite of this one. This will be NP, NP, and then again this PN, PN, like this. So let us start. Second question. Second question says to operate an NPN transistor in the active region, it emitted base and collector base junction respectively should be. Okay, आपके पास NPN transistor है. Okay, NPN transistor, इसको एक्टिव में काम कराना है. तो एक्टिव के लिए मैंने आपको चार तरह के बायसिंग हो सकती है. Okay, you have a emitter based junction and collector based junction. Okay, one is forward bias, which is called FF biasing. Okay, and this will give you operation region. This will give you saturation region. Okay, if you put forward reverse, this will give you active region. Okay, if you give reverse forward, okay, that is just a inversion, no use. That is just an inversion, opposite to this active. Okay, this is no use. And last is your reverse. This will give you cutoff. Okay, so always your emitter to base junction should be forward bias. Okay, emitter base junction should be forward bias, and collector base junction should be reverse bias for active region. Okay, you have to check this, check the sign of voltages, whether your emitter base junction is forward bias or not. Okay, therefore you have to check the sides. So this is the option correct. What is the option?
Option A, sir.
Option A. Okay, so emitter base junction should be forward bias and collector base junction should be reverse bias. Option A is correct. Okay, similarly the third question is also similar type. For using the transistor as an amplifier, choose the correct option regarding the resistances of base emitter and collector base junction. Okay, so you are using transistor as an amplifier. Okay, any transistor you take PNP or NPN transistor, whatever you want to take, okay, in any mode. If you are taking the, suppose I'm taking a PNP transistor, this is my ammeter, this is my base, this is my collector, okay, and I want to use, say, this is a common base. We are applying some input here, I'm getting some output here, okay, or I can use this like this also, common, say PNP, P and P. This is my ammeter, base, collector, or collector, base, ammeter, collector, base, ammeter. If this is my ammeter is grounded, okay. So you know, amplifier, this means what? Amplifier means there are three currents in the transistor. One is called IE, IB, and IC. Okay. So if you if you use a common base configuration, this IE is almost equal to IC because IB is negligible. Current is this one. Okay. But if you talk about a resistance of collector base junction is always very high. Then only amplification is possible. If you see the IC versus VBC, okay. If you see output characteristics of output characteristics, okay, how it comes? It comes like this. YBC or YCB, okay, whatever. This character is like this. If you plot the input resistance, input characteristics, input current is IE, and you're applying voltage here, say VBE. This is like this. This is like diodes. So your EB junction, if you take the resistance, this will come ohms. This will come in mega ohms. So EB junction का resistance हमेशा कम होता है. EB junction resistance is low. Well, your CB junction, the resistance is very high. So that's why only एम्प्लीफिकेशन पॉसिबल है. एम्प्लीफिकेशन में देखो यहाँ पे करंट बराबर है, तो करंट बराबर है. अब आपको आई स्क्वायर आर को ज्यादा करना है, वोल्टेज को ज्यादा करना है. तो वोल्टेज ज्यादा करने के लिए करंट सेम है, तो आई आर शुड बी ग्रेटर देन आई शुड आउटपुट रेजिस्टेंस शुड बी ग्रेटर. When output resistance is greater, then only I into R will become voltage output will become more, or I square R. I is almost same here, so R should be changed. Okay, so here this junction CB junction resistance will be very high. You can see with this plot also. This is infinite. This is signature of infinite resistance. Okay, always parallel to this voltage axis, and this is a ohms. So the current transition. Similarly here also. Here your input current, my input current is your IB. If you say common ammeter, and your output current is IC. So IC is very high. Okay, and if you plot a graph of IC versus VCE for common ammeter, we have seen the graph will come slightly tilted. And if you plot IB versus VBE, that is like the same. So input resistance, input EB junction always have a less resistance, while CB junction has a very high resistance. So in common ammeter configuration, your resistance is high less compared to this one, but the current gain is very high. So overall amplification is very high in the common ammeter configuration. That's why we do always prefer common ammeter configuration. हमने जितने भी क्वेश्चन करे हैं अभी तक सारे के सारे में हमने कॉमन ammeter configuration ही यूज किया है. एग्जाम में भी मोस्ट ऑफ क्वेश्चन जो कॉमन एमिटर कॉन्फ़िगरेशन के आते हैं, क्यों आते हैं? क्योंकि रेजिस्टेंस तो इसमें ज्यादा है, कॉम्बिनेशनल बेस में ज्यादा है आउटपुट का कंपेयर टू इनपुट के. दे मोर पैरेलल, दे मोर आइडियल लाइक एम्पलीफायर. बट यहाँ पर क्या है, करंट गेन नहीं है इस कॉन्फ़िगरेशन में, करंट गेन नहीं है. आई इनपुट करंट एंड आउटपुट करंट IC ऑलमोस्ट इक्वल, सो वोल्टेज गेन इज लेस हियर. Okay, while here you have a current gain as well. Input current is IB, output current is IC, and IC is beta IB. So you have a current gain as well, and resistance ज़्यादा है ही, इससे कम है लेकिन फिर भी ज़्यादा ही है. So overall amplification is better with common ammeter configuration. Okay, so EB junction will be low and BC junction resistance will be high. That always you remember. Okay, what is the option? So what is the option?
Option B, sir.
Option B में very low RB and very high RBC. So collector based resistance हमेशा high ही होगा आपका, ठीक है. Okay. So next question is, in the given circuit VCC is 10 volt, beta is 100. Okay. Asking collector voltage VC. So you in common emitter configuration में दे रखा है आपका ट्रांजिस्टर. This is 1 kilo ohm. This VCC which is 10 volt is given. Okay. And beta is given 100. This is your 100K. Okay. And this is your 5 volt. Okay. And this is your common emitter. This is your ground. This is your ground. So let us solve now. We have to find the VC. VC means here voltage. This is the collector. This is the base. This is your emitter. So VC I want to find here. So VC मुझे ये find करना है, तो VC क्या होगा? VC हमेशा ये VCC है. VCC या इस वोल्टेज से यहाँ पे ड्रॉप कितना होगा? IC
माइनस ICRC.
और ICRC. तो आपको पहले
Yes, sir.
IC निकालना है. IC क्या होता है? बीटा IB होता है. बीटा आपको दे रखा है, IB निकालना है. IB आपका डिस सर्किट से आ जाएगा. तो IB आपको कितना आ जाएगा इस सर्किट से? -5 प्लस if IB current is flowing here, IE current flowing here, IC current flowing here. So this is -5 IBRB. Okay, this is VB, which is generally 0.7. Sometimes you can take 0 also. Okay, so that depends. Okay, now if you want IB, so IB will be -5 into 0 divided by 0.7, and this is 100 kilo. So this will come how much? 4.3. And this is 10 raised to power 5, that is 43 microampere. Okay, so your IC will be what? IC will be 100 into 43. Okay, कितना आ जाएगा? 10 raised to power 4.3
4.3 milliampere.
4.3 milliampere आ जाएगा. अब VC आपको निकालना है, ये वाला you just want to calculate this VC, this point. So this will be VCC 10, ये minus 4.3 into milliampere into 1 किलो ओम. कैंसिल हो गया ये किलो ओम मिली एम्पियर से. तो कितना आएगा? 10 4 - 3 5.7 वोल्ट आना चाहिए आंसर. 5.7. ओके, अगर इसको जीरो जीरो ले लोगे तो ये 6 वोल्ट आ जाएगा. सो द आंसर शुड बी 5.7 वोल्ट. चेक करो कितना आ रहा है. आ रहा है क्या?
Yes, sir.
ठीक है. Now let us say take second question. Second question क्या है? Next question is your, for the following circuit, the collector voltage with respect to ground will be, the collector voltage with respect to the ground VC पूछा है. Ammeter diode voltage. Okay, ammeter diode voltage, that VB is 0.7 and beta DC is very large. Okay, so ये क्वेश्चन इंटरेस्टिंग है थोड़ा. देखो इसको, ऐसे क्वेश्चंस को कैसे करेंगे. So this is your question. यहाँ पे एक रेजिस्टेंस दे दिया है 3 किलो ओम, and this is your 1 kilo ohm, and here -3 volt battery is given. Here a resistance is given 3 kilo ohm, and this is your +10 volt. Okay, now you're asking VCE. Okay, what is the collector voltage with respect to the ground? VC पूछा है. collector voltage with respect to the ground VC पूछा है हमको. अगेन ये वोल्टेज पूछा है VC। ओके, सो अब ये क्वेश्चन कैसे करेंगे? यहाँ पे सपोज यू से दिस IB is flowing here, is I flowing here, IB is flowing here, and beta DC value is not given. This is very large. Say very large. Okay. Now if I apply, suppose current is flowing here, so IB is flowing here. So if I write, okay, तो कैसे कैसे लिखूंगा मैं? IB 3 kilo ohm multiply by this kilo ohm. Okay, so I call this say RB. I call this as RE. Say, so I'll write equation IB RB. Okay, I write VB. Then I'll write IERE, this current, this voltage, and this finally minus 3 volt, and then equal to 0. Is this correct equation or not? Tell me.
Yes, sir.
IBRB plus VBE, IERE, and then minus 3 volt. Whatever sign is coming, if current is flowing like this, so voltage drop is like this. Current is flowing like this, so voltage drop is like this. And it's a minus 3, so I'm putting exactly what sign is coming. I'm putting that sign, and I'm writing the Kirchhoff voltage law. Okay. Now the question is, you have to find what? You want to find this you want VC. So VC will be only, you can calculate VCC minus ICRC. So you want IC. Okay. Now from this equation, you can calculate IE, because what is there? If you can write IB, you can write IE upon RB, IE upon beta, because your IC is beta IB and IC is almost equal to IE. Okay, so I can say my IB is equals to IE upon beta. Yes or no? Okay, and then your resistance here is 3 kilo ohm. Okay, BB is your 0.7 volt. IE you want to calculate. RE is your 1 kilo ohm. Minus 3 equals to 0. Now if you want, you can put this term as a negligible also, because this is IE. Okay, now if you take common this one, okay, so let us see what will run. If you take common, if I take IE common, क्या आएगा? IE, this will be 3 into 10 to the power 3 upon beta, plus this will come 1 into 10 to the power 3. Okay, and this is your plus 3 minus 0.7. Yes or no? So now
Yes, sir.
now this beta is, now this is 1 kilo ohm, this is 3 kilo ohm, but this beta may be very large. Suppose you even you take 100. If you take this 100, then this become 0.03. This is 1. So always this part you can always neglect. Okay, that means this part you can always neglect. That means you can say IB is neglected. Okay, directly you can neglect IB, because IB is always in microampere. Okay, so you can neglect IB, so this term will not come, or you can neglect here because this is very high. So you can say almost equal to your IE is equal to almost equal to, you neglect this one. So this is 3 minus 0.7, this is 2.3, and this is your 1 kilo ohm will go down, 1 kilo ohm down here. So this is comes to 2.3 milliampere. Okay, now you know the IE value, so you can calculate here. I is almost equal to IC, so you can put 2.3 here. So this is your 10 minus 2.3, RC is your 3. Okay, so 10 minus 339.6. Okay, so this should come around how much? 3.1 volt. Check the answer. VC should come 3.1 volt. Because directly you can find the IE from this equation. Okay, neglecting this is almost equal to 0, or compared to neglecting compared to this term. Okay, this term is, I'm writing here 3 into 10 to the power 3 beta is less than 1 to 10 to the power 3, because beta is very large. Beta is very large. Okay, 100 very large, very 500,000. Okay, whatever. This is less. So solving this one, we get current, and we put the current value, we get this voltage. Okay, so this should come around 3.1 volt. Check the answer.
यही है सर।
सो क्वेश्चंस ट्रांजिस्टर के तो बड़े सिंपल है। ट्रांजिस्टर में यू ओनली शुड नो हाउ टू अप्लाई केवीएल, दैट्स इट। अगर आपको किरचॉफ वोल्टेज लॉ लगाना आता है, आप केयरफुली लगा दोगे तो पॉसिबिलिटी क्वेश्चन गलत होने की बहुत कम है। ओके, let us solve next question. In the transistor circuit given in the figure, the emitter base junction has a voltage drop of 0 volt. सब इतने क्वेश्चन है। एक कलेक्टर एमिटर वोल्टेज 14 वोल्ट, रिवर्स बायस द कलेक्टर। ओके, सो आपकी VC आपको दे दिया है। Assuming the collector current to be the same as the emitter current, the value of RB is, तो इस क्वेश्चन में RB का वैल्यू दे दिया है आपको, VC आपको गिवन है। सो दिस इज 20 वोल्ट RB। अगेन कॉमन एमीटर कॉन्फ़िगरेशन नहीं करना है आपको। 1 किलो ओम दे रखा है एंड दिस इज योर 2 किलो ओम और बीटा आपको 100 दे दिया है। ओके, आपको RB निकालना है। सो RB निकालने के लिए क्या करेंगे, देखिए ये आपका RB है। VC आपको कितना दे रखा है क्वेश्चन में, VC कितना दे रखा है?
14 वोल्ट सर।
13 वोल्ट है।
14 वोल्ट।
14 वोल्ट दे रखा है आपको। ओके, चलो तो कैसे करेंगे इसको, BCE। ओके, VB आपको 0.7 ले लेना, आपको VB दे रखा है आपको। ओके, सो ये इक्वेशन लिखो पहले यहाँ से इनपुट में। इनपुट में क्या आएगा, -20 IB। आपका आपको VC दे रखा है ना, तो VC क्या होता है, VC माइनस VE इक्वल्स टू 14 वोल्ट दे रखा है आपको। ओके, और सो लेट अस से कैसे करेंगे इसको, बताओ कैसे करेंगे इसको। लेट फर्स्ट बी राइट द
सर
इक्वेशन।
इक्वेशन
हाँ,
क्या IC का
VCC
VCC by VCE
VCC इक्वल टू
by RC
ICRC
plus RE।
ICRC
प्लस VCE
प्लस VCE, वेरी गुड। ICRC VCE
प्लस
प्लस
IERE।
IE, वेरी गुड। IE
IE को हम IC भी ले सकते हैं, क्वेश्चन
हाँ,
में बोला
सो
है।
तो ये ऑलमोस्ट सेम है, तो यू कैन पुट IC इक्वल टू RC प्लस RE प्लस VC। ओके, तो आपको सब दे रखा है, VCC दे रखा है, VC दे रखा है, RCR देखा, तो यू कैन फाइंड द IC वेरी इजीली। IC पता चल गया तो IB पता चल जाएगा इस इक्वेशन में। ओके, सो आपका VCC दे रखा है 20 वोल्ट्स। ओके, माइनस दिस इज 14, like RC is 2 and 1 3, this is 3 kilo ohm। 2 minus 14 will come 6 upon 3 kilo ohm, that is 2 milliampere, current is 2 milliampere IC, and is 100 is there, so your IB will be automatically 2 milliampere divided by 100, that is 10 to the power minus 5 or 10, 20 microampere, that becomes 20 microampere. So now you can write equation here, -20 plus IB RB plus VB plus IE मतलब ICRC ICRE। ओके, IC को पता ही है, इक्वल्स टू 0। सो आपका IB क्या आ जाएगा, RB क्या आ जाएगा, RB, इसको भी आप लिख सकते हो IB को, यू कैन राइट व्हाट, IB तो आपको पता, क्वेश्चन में IB दे रखा है वैसे तो IC भी पता है आपको, दोनों पता है, डायरेक्ट RB निकल ही जाएगा आपका। सो RB विल बी योर 20 minus 0.7। ओके, इसको आपको लाना पड़ेगा बीटा IB, दिस विल बी बीटा IB, तभी तो कॉमन निकलेगा। नहीं क्या कि डायरेक्ट माइनस हो जाएगा, डायरेक्ट माइनस कर सकते हो, डायरेक्ट माइनस कर सकते हो, डायरेक्ट। दिस इज ICRE, सो दिस इज 20 minus 0.7 minus IC is 2 milliampere, RE is 1 kilo ohm. ये सब डायरेक्ट माइनस हो गया, डिवाइड बाय ओनली IB कम. ओके, सो इसको सॉल्व कर सकते हो, थोड़ा सा मैथमेटिक्स है, कैलकुलेशंस. तो आरबी क्या आ जाएगा आपका 10 माइनस, ये कितना हो जाएगा, दिस 2 वोल्ट, 18 वोल्ट, 18 माइनस 0.7, 17.3 वोल्ट, 7.3 वोल्ट. और आईबी कितना दे रखा है आपको, 20 माइक्रो एम्पीयर दे दिया है. बताओ कितना आ रहा है आरबी,
865 किलो ओम.
865 किलो. That's the answer. तो साइंस के क्वेश्चंस में कैलकुलेशन भी आसान है, सर्किट भी आसान है. ओके, खाली यू हैव टू डू केवीएल, साइन का मिस्टेक नहीं करना है, otherwise everything is fine. Okay, let us say question number 7. Okay, in the circuit given below, the collector to emitter voltage BC is, okay, BC पूछा है क्वेश्चन के अंदर, वोल्टेज डिवाइडर का क्वेश्चन है, वोल्टेज डिवाइडर का क्वेश्चन है. So you have been given ट्रांजिस्टर दे दिया आपको, VCC दे दिया है आपको, नहीं इसमें ऐसा दिया है, वोल्टेज डिवाइडर दिया है ना, तो दिस इज वोल्टेज डिवाइडर, हाँ करेक्ट, एंड दिस इज कमिंग हियर लाइक दिस, like this. Okay, here भी resistance दे दिया है, this one, and this is your VCC. Okay, ऊपर बना दिया मैंने, just 1 minute. So this is your कॉमन एमीटर VCC. VCC का वैल्यू कितना दे रखा है बताओ, VCC
10 वोल्ट है
10
VCC.
volt, sir.
10 वोल्ट है, and this is 5 kilo ohm, and this is your 5 kilo ohm, this is 10 kilo ohm, this is the 5 kilo ohm. Okay, क्वेश्चन में पूछा है कितना है आपका VCE, और बीटा दे रखा है क्या, बीटा 100 दे रखा है आपको, नेगलेक्ट बोल दिया नेगलेक्ट VBE, और बीटा आपको दे दिया है 100, neglect VBE. Okay, so this question you can do it two ways. One is accurate method, other is the approximation method. So I am using the approximation method. Okay, approximation method says you assume there is no current here, IB, so this voltage getting divided here, so you can easily find what is VB. Okay, so neglecting IB, if I'm neglecting this IB, I'm saying no current is going here, so the automatic current is coming here only. Okay, so I can find that this is a voltage divider circuit, so I can find VB, this voltage VB, this voltage will become how much, VCC upon R1 R2, that is 10 kilo ohm, R1 I'm writing this is R1 and this is R2, so R1 plus R2, and I want voltage, this voltage because this is the ground, this voltage VB, which is multiply R2, the VCC is your 10, R1 is 10 kilo ohm, and this is your 5 kilo ohm. This is 1, this is 2, this is 1, this is 5. So your VB coming 5 volt. Okay. Now your BB is what BB is question में दे रखा है BB is VB minus VE and question में ये negligible दे रखा है, it is given 0. So your VB this is negligible. So your VB almost equal to your VE. So you know this voltage VE now. So this is also 5 volts. So this voltage you know, this resistance you know, so obviously this current IE you know. So IE will be what? IE will be your
So V by RE.
5 volt upon 10 kilo ohm.
Yes, sir.
तो कितना आ जाएगा बताओ?
0.5 milliampere.
कितना?
Sir, 0.5 milliampere.
0.5 milliampere.
0.5 milliampere. I आपको मिल गया. अब I is almost equal to your IC. Okay. So you can find, you know, VC is given. तो क्वेश्चन में पूछा क्या है? क्या पूछा है आपसे बताओ? VC पूछा है. तो V आपको पता है VE, which is V is equal to 5 volt. You find the VC and then you can find the VCE. तो VC कैसे निकलेगा? VC जैसे हमेशा निकालते हैं. VC is what? VC is your VCC minus ICRC. Okay. It is 10. IC is your 0.5 milliampere. Okay. And RC is your 5 kilo ohm. 5 kilo ohm. तो किलो ओम तो कैंसिल हो गया. ये हो गया 5 into 0.5, 2.5, 10. That is you got 7.5 volt.
7.5.
तो VC आपको कितना हो जाएगा? VC 7.5 volt and VE. Okay. VC minus VE. That is 7.5 minus VE is आपको 5 volts. तो ये आ जाएगा आपका VC 2.5 volt. आ रहा है क्या? चेक करो.
Yes, sir. आ रहा है, sir.
Yes, sir.
Anyone else who has confusion? Okay. Durvi, Omega, Shekhar.
No, sir.
So ये voltage divider important है. इसको याद रखना. You can do with the accurate method and you can do with the approximation method. Both method you can use. Let us do the next question. Question number 8. NPN transistors given connected to circuit is shown in the figure. If IC की value दे रखा है 1 milliampere, beta given, VB given, and current through R2 is given 10 IB, where IB is the base current. Ratio पूछा है. Again you have this voltage divider circuit. Okay. Again this is a voltage divider circuit. This is given you 6 volt. Okay. IC is given 1 milliampere. Beta is given 50 and VBE is given 0.7. Okay. And you have to find the ratio of R2 by R1. Okay. R1 by R2 पूछा है. R1 upon R2 का ratio पूछा है. And they say that the current through R2 is 10 IB. Current through R2 is 10 IB. Here current is 10 IB. Then what is the ratio? Okay, let us solve. So here resistance is there 2.5 kilo ohm. Here also resistance is there 2.5 kilo ohm, and here this resistance is given 0.5 kilo ohm. Okay. So this is 10 IB. Okay. So if I assume neglect this current, automatically current here also 10 IB R1. Okay. So you can find the voltage VB. VB will be what again? 6 upon R1 plus R2. R1 plus R2 into R2. This is VB. Okay. Now IC is given 1 milliampere. Question में IC दे रखा है आपको. IC is given 1 milliampere and your IC is almost equal to IE. So I can find what is my VE here with respect to the ground. So my VE will become IE into RE. और IE कितना है? IE is 1 milliampere given. 1 milliampere is given. RE is 0.5 kilo ohm. This cancels, so this comes 0.5 volt. So my V is 0.5 volt. Okay. So V is 0.5 volt. So I can find what is VB. So my VB will be equal to VBE plus VE. VB is 0.7 volt and V is 0.5 volt. So VB comes out 1.2 volts. Okay. So this VB is 1.2 volts. So 1.2 volt, 6 R1 plus R2 into R2. You can solve this one. So this how much can 1.2 R1 plus 1.2 R2 and this is 6 R2. Okay, and if we solve this one, 1.2 R1 and this 1.2 R2 here goes, this comes out 4.8 R2. Okay, this implies R1 upon R2, 4.8 divided by 1.2. This is comes out how much? कितना आएगा बताओ? 4 upon 1? 4 आएगा आंसर. ये तो क्वेश्चन क्लास में करा हुआ है मेरा पहले भी.
0.25 सर.
हाँ?
आंसर है 0.25.
तो उल्टा
नहीं सर, वो ऑप्शंस गलत है सर, उसमें क्वेश्चन गलत हो गया था वो आईआईटी का.
हाँ, तो वो R2 बाय R1 दे दिया होगा उसकी जगह पे. R1 का R2 जगह
हाँ
पूछना,
सर.
उल्टा पूछ रहा होगा, ये आ गया था होगा. ठीक है. क्वेश्चन नंबर 9 देख लो. अमीटर करंट पूछा है क्वेश्चन नंबर 9 में. अमीटर करंट. अब मैंने एक दो क्वेश्चन नेट का भी, गेट का नेट भी डाल दिया है इसके अंदर, क्योंकि वो क्वेश्चन है सिंपल. ओके, तो आपकी जैसे क्वेश्चन है तो उसमें कुछ एक आध कंसेप्ट कवर हो जाते हैं, तो वो भी डाल दिया मैंने. एक आध क्वेश्चन गेट का, एक क्वेश्चन गेट का, एक जेस्ट का, एक नेट का डाल दिया है. तो लेट अस सी क्वेश्चन नंबर, ताकि आपके ज़्यादा से ज़्यादा कंसेप्ट आपके कवर हो जाए ना. खाली जम के क्वेश्चन करेंगे तो फिर क्वेश्चन कवर नहीं हो रहे थे. ओके, सो VCC इज गिवन, क्वेश्चन इज गिवन. क्लास में तो हमने सारे करे ही हैं. दिस इज 2 मेगा ओम. ओके, दिस इज 4 किलो ओम. This is 10 volt. Okay, this is 2 kilo ohm here, 2 kilo ohm, and this is given 0.3 volt. VB this time given 0.3 volt because germanium transistor है, germanium transistor, and beta is given 100. Okay, तो अमीटर करंट पूछा है, अमीटर करंट. सो क्वेश्चन तो आसान ही है. IB निकाल लो, and then if you know IB, you can find the IE very easily. Okay, so this time only this is a new thing. You have given 0.3 here. बाकी तो सेम ही है, -10. Okay, what is the battery? 10 volts, so minus plus, so minus plus 2 mega ohm into IB current is flowing here. IB. Okay, this IB going here, and the drop is here VBE. VBE, and then you have current here IE. IE, which is beta plus 1 IB or beta IB. This become beta plus 1 IB RE equals to 0. So from here you can find the IB value. How much will come? IB will come 10 minus 0.7, 0.3. 10 minus 0.3, this is 0.3 this time. Okay. And beta plus 1, this is 100, 101 into RE. RE is 2 kilo ohm. Okay. Plus this resistance value 2 mega ohm, 2 into 10 raised to power 6. Okay. So this will give you IB value. This give you 0.3, 9.7. Okay. ये मेगा ओम है, ये कितना आएगा? ये मैक्सिमम उसको 100 मान लो, तो ये 10 to power 5, 10 to power 5 समथिंग कुछ ऐड हो जाएगा. ओके, 2 पॉइंट समथिंग आएगा. कितना आ रहा है? सॉल्व दिस वन. So if I assume this
Sir,
one,
इसका आंसर है 444.9
so
माइक्रोएम्पियर.
मैं इसको ऐसा लिख सकता हूँ, अराउंड 2.2 ऑलमोस्ट. ओके, 2.2 मेगा ओम almost. Okay, this will be IB and you want IE. So IB will be beta plus 1, so 9.7, almost 2.2, 10 to the power 6, and into beta IB या beta plus 1 IB 101. इसको सॉल्व करके बताओ कितना आ रहा है.
सर ये आ रहा है आपको 444.9 माइक्रोएम्पियर.
ठीक है, तो क्वेश्चन में तो कुछ है नहीं इसमें भी. अब ये क्वेश्चन नंबर 10 तुम करके दिखाओ कितना आएगा. सेम क्वेश्चन रिपीट हो रहे हैं. क्वेश्चन नंबर 10 एग्जैक्टली वोल्टेज डिवाइडर सर्किट पूछा है. अब तुम लोग निकाल के बताओ. मैं नहीं निकाल रहा, मैं क्वेश्चन लिख रहा हूँ. आप सॉल्व करके दिखाओ, मैं सबसे पूछूंगा. ये क्वेश्चन अभी खुद कर लोगे तो तुम्हारा प्रैक्टिस हो जाएगा ना. और ये क्वेश्चन इतना इंपॉर्टेंट है, डिवाइडर का है, तो अभी अपने आप कर लोगे तो तुम्हारा रिवीजन भी हो जाएगा. सो दिस इज सॉल्यूशन. देखना नहीं है, ऐसे सॉल्व करना है. ठीक है. R1, R2, R1, R2, and then you have RE. Okay, RC and VCC. This is VCC. Okay, so VCC given 15 volt. Okay, R1 आपका देखा है 100 kilo ohm, and this is 50 kilo ohm. RC is 4.7 kilo ohm and RE is 3.3 kilo ohm. आपसे पूछा क्या है क्वेश्चन में, व्हाट इज VC? बताओ कितना आएगा VC. आई एम गिविंग यू 5 मिनट्स, सॉल्व करके बताओ. क्वेश्चन में VB दे रखा है क्या?
सर इसका आंसर आ रहा है 8.9 वोल्ट सर।
हाँ
8.88 वोल्ट सर।
8.8, सो 0.7 वोल्ट दे रखा है इसमें, VB 0.7 दे रखा है। ओके, तो वैसे ही आपको VB निकालना है। ओके, VB क्या आएगा आपका? VB आपका VCC अपॉन R1 प्लस R2 150 किलो ओम इंटू 50 किलो ओम। So this is 1, this is 3, so VB आपका 5 वोल्ट आ गया, 5 वोल्ट। अब VB आपको दे रखा है और ये आपको दे रखा है 0.7, तो आपका VB क्या होता है? VB प्लस V, तो आपको V चाहिए, तो 5 वोल्ट में से 0.7 यहाँ यूज हो गया, तो आपका V आ गया आपका 4.5 माइनस 0.7, ओके, दैट इज 4.3 वोल्ट। ओके, अब 4.3 वोल्ट क्या आ गया, तो यहाँ से आपको करंट मिल जाएगा I आपको हो जाएगा VE 4.3 डिवाइड बाय 3.3 किलो ओम। कितना आ रहा है ये I कितना आ रहा है?
1.30
1.
IE।
हाँ 1.3 है ना,
मिली
1.3
एम्पियर सर।
यस सर, मिली एम्पियर।
मिली एम्पियर। तो ये I आ गया, तो IC मिल गया, तो आपका VC क्या हो जाएगा? VCC 15 माइनस IC 1.3 इंटू 4.7 मिली एम्पियर, और किलो ओम कैंसिल हो जाएगा, तो ये सॉल्व करके देख लो जितना भी आएगा। 1.3 इंटू 4.7 कितना होता है?
6.12।
6.12, तो माइनस करके जो आएगा
8.88
8.9 सर।
जो भी है 8 अप्रोक्सीमेटली दे लो, जो भी एग्जाम में क्वेश्चन दे रखा
वोल्ट
है,
सर।
ठीक है ले लो।
ऑप्शन है।
6.1 ले लोगे तो क्या आ जाएगा? 8.9 ही आ जाएगा। ठीक, so next question is, consider the following circuit in which the current gain beta DC is given 100. okay, तो आपको पूछा है कौन सा लोड लाइन करेक्ट है। बेसिकली आपको पूछा है, आपको सर्किट का लोड लाइन पूछा है, लोड लाइन एंड ऑपरेटिंग पॉइंट पूछा है। तो सर्किट, अभी इस क्वेश्चन को ध्यान से देखना, ऐसा क्वेश्चन आया नहीं है। ये दो क्वेश्चन जो करा रहा हूँ उसको अच्छे से देख लो। यू हैव this transistor, this is your 100 ohm, okay, this is your 15 volt, this is your 100 kilo ohm, okay, and this is 900 ohm, 900 ohm, okay, 100 ohm, and this is this one, okay। so load line का मतलब क्या है? आउटपुट कैरेक्टरिस्टिक्स है, ओके। तो आपको पहले तो आउटपुट कैरेक्टरिस्टिक्स ड्रॉ करना, और लोड लाइन के जो एंड पॉइंट्स हैं वो ड्रॉ करके आने चाहिए, ओके। सो बेसिकली द ग्राफ इज बिटवीन IC and BCE, okay। now the equation, you know all what is the output equation. Output equation is, if you want BCE, this VCE, that equation is equal to basically VCC minus IC RC plus RE, okay। So this VCC is getting drop here, ICRC BCE plus IERE, which is ICRE, okay। So I am writing this equation like this. This is the equation, okay। Now you have to write the end point of this equation. So end point of this VC can be 0. When VC is 0, this is VC is 0, then this IC value will be IC saturation. So if you want to calculate IC saturation, so circuit में maximum possible value क्या है IC की? The maximum possible value is IC saturation, okay, which is equal to VCC upon RC plus RE. BCC is what? BCC is 15 volt. RC is 900 plus 100. This becomes 1000 kilo ohm. 1000. So this become IC become almost how much? 15 milliampere. This is a 15 milliampere. So if I take my BC0, this point should be 15 milliampere. So this point should be basically 0, 15 milliampere. So this is one point in this equation I can put. And this question, if I go in the x-axis पे IC 0 है. If you put IC 0, your VC will come to VCC. VCC is again 15 volt. So this point is your again 15 0. तो सबसे पहले तो ये आपका लोड लाइन है. तो जो ये लोड लाइन नहीं हो उसको हटा दो पहले तो. एंड पॉइंट्स आर दिस वन. Okay, so end points are basically this is 15 milliampere IC saturation, and this is your 15 VC equal to VCC, VC equal to VCC, which is 15 volt is the end points of this graph. Okay, now you want to find operating point. Operating point के लिए you first calculate the beta is given. Beta question में 100 दे रखा है ना. So first you calculate IB in this circuit. IB. So IB will be what? IB will be your VCC minus VBE. Okay, and then IBRB, and then this one, this is beta plus 1, IB, beta plus 1 RE. This is the equation of IB, that is 15 minus 0.7, RB is 100 kilo ohm, plus if it is 100 ohm and this is 100, I'll take this 100. So 100, how much? 10 raised to power 4. Okay. So this becomes 15 minus 14.3 and 10 raised to power 5 and 10 raised to power 4. Okay. So I can almost I can take this 10 raised to power 5 because this is a 0.1 only. It will add only 1.1 something. Okay. So this will come around how much? Tell me. 143 microampere. Okay. Now if this is 143 microampere, almost, okay, if it is one, then your IC will be 100 into 143. How much? 1.43 microampere, 14.3 microampere, milliampere. Yes or no?
Yes, sir.
So
Yes, sir.
14.3 milliampere is less than 15 milliampere, which is your IC saturation. Okay, that means the actual current value is this one. If IC comes greater than this one, then the actual value will be this one, because current maximum value only can be 15 milliampere. If it is less, it is fine. So this is your correct value IC. If question IC comes out greater than this one, then that greater value will not be actual value. Actual value will be your this one, because this is the maximum value possible. So here it's coming less. So this is my I am satisfied. This is my actual value IC. Okay. Now I can find my operating point. I got this one. कितना आ रहा है वैसे तुम लोग का ऑप्शन में कितना आ रहा है? ऑप्शन में कितना आ रहा है आईसी का?
ऑप्शन में सर एक ग्राफ पर 13 है.
13 है तो मतलब
13 मिलियन.
तो कैलकुलेशन में कुछ हमने ना छोड़ा है हमने उसी के लिए आ रहा होगा ये. ओके, सो विल सी, क्योंकि हमने यहाँ पे कुछ डिवाइड वगैरह में कुछ छोड़ा है तो उसकी वजह से हमारा कुछ कम आएगा. ठीक है. सो अब मैं यही ले रहा हूँ 14.3 and now this 40, this is IC value, so I can find my VCE. VCE कितना आएगा बताओ? तो VCE will be my
2 volt, sir.
VCC कितना 15 minus IC is 14.3. okay, IC and IC plus RE, this is 1000. This is 1000 तो milliampere kilo ohm कट जाएगा, कैंसिल हो जाएगा. तो कितना आ रहा है? मेरा आ रहा है 1.7 वोल्ट. 1.7 वोल्ट. So 1.7 volt and 14.3 milliampere. This is the correct option. Now, if you say no, this is not 14, this is 13. and this 2. So this current decreases, so automatically this will increase. So I may have done some approximation here. If you do exact calculation, you may get this is 13.
सर एग्जैक्ट से 13 ही आ रहा, अगर
13
एग्जैक्ट कर देंगे तो 13 आ जा रहा। हाँ
एग्जिट कर 13 आ जा रहा है ना, ठीक है, एग्जिट कर लोगे तो 13 आ जा रहा, तो ठीक है। देन दिस विल बी 13 plus 2 plus 13, so this will be 2 volt and this 13 milliampere current. So this is your operating point. अगर ऑपरेटिंग पॉइंट में ये IC is greater than 15, then the operating point will be this one. Automatically VC will be 0 whenever your IC in the question is greater than IC saturation. That means your circuit is in the saturation. Then, or if it suppose this comes out 16 ohm, 16 milliampere, then automatically this will be your operating point, and VC will be 0. That you have to remember, because IC cannot be greater than IC saturation. So while solving this question, you have to remember. So this is the correct question, correct option. Now let us solve one more question. Now you have been given, this is a mirror circuit, okay? I purposely put this question. This is the transistor mirror circuit. Both base have connected, okay? And here you have current I naught, and this is your, here you have a 5 kilo ohm resistance, and this is your VC. C is given 30 volt, okay, and this is, both are grounded. So question में पूछा है, what is the value of IC, I naught, ये वाला पूछा है I naught, okay, beta given and VB given. Beta is 0, beta is 100 and VB is 0.7 volt. Now both the transistors are what? Both the transistors are your identical, okay, and this is connected here. So both the transistors are connected here, okay. So basically this is your IC going here, okay, this IB going here, this IB going here. Both are identical. Here also 0.7, this is 0.7, and say this is current I, total current I coming. So this total current I coming, this I is equal to what? IC is going here in this here, and this 2IB going here. This is my I. Okay. So from here you can find, now this IC is again beta IB. This is 2IB. So this is beta plus 2IB. Okay. So my IB will be equal to what? IB will be equal to I upon beta plus 2. So that means if I know IB, automatically I know this, what is the I naught. So my I naught will be what? I naught here is IC. So here I naught will be my beta IB. That means this will be beta I upon, and I will call this a reference current. Reference current beta upon beta plus 2. Okay. So automatically if I know this current, I know this current. And these two currents are, this current and this current are almost same. You can see, if beta is large, so this can cancel out. This I naught is almost equal to IR, but slightly difference. Okay. So this is a mirror circuit. If I flow this current will flow every transistor which is connected like this. Here 2 transistors, there may be 3, 4, 5. So this is the formula. Okay, here 2 are there, 2, 3 is 3, 4 is 4, beta is 4, beta 5, 5 is 5. So now you have to find only I naught or IR. Let us find IR. So IR I can find from this circuit. You can go anywhere. Okay. So this is 30 volt VCC. Okay. This is VCC minus IR into 5 kilo ohm. 5 kilo ohm. And then I come here VB 0.7 volt equals to 0. So my IR is plus minus VCC plus So my IR will be VCC, that is 30 minus 0.7 upon 5 kilo ohm. Okay, how much is coming? This is 29.3. This is 5 kilo ohm. कितना आ रहा है IR?
सर ये आ रहा है आपका 5.86 माइक्रो एम्पियर एम्पियर मिली एम्पियर सॉरी मिली एम्पियर
5.6 milliampere. Okay, and you put the value here. So I naught भी इतना ही आएगा. Beta is your 100 into 4.86 upon 102. ये कितना आ रहा है?
सर 5.86 है, आपने 4 लिख दिया।
5.86.
5 सर 5.86
तो इतना ही ऑलमोस्ट इतना ही आएगा ये भी. 5.8, थोड़ा सा कम मिली एम्पियर, और 7 जो भी है आंसर. ये पॉइंट क्लियर है सबको?
यस सर
नादिर, ध्रुवी, ओके. तो जो मैंने कराया एटलीस्ट क्लास में वो सब कॉपी में वो सब करके जाना. ज़्यादा नहीं है ट्रांजिस्टर में. ओके, नाउ क्वेश्चन नंबर 13 and 14. Question number 13. Okay. So you have been given two circuit, okay? And उसको बताना है उनका बीटा दे रखा है 100 and 10 respectively, then they operate. इनका दोनों सर्किट का ऑपरेशन रीजन बताना है आपको. ऑपरेशन रीजन बताना है. अब तुम लोग बताओगे कैसे निकालोगे. मैं नहीं करूँगा इस क्वेश्चन को. 10K, 10.7, and this is your 2K, and this is your 10 volt. This is connected like this. So this is circuit A. Okay, इसमें बीटा 100 है. And a circuit, next circuit is you have transistor, this one, 10K, and you have this 5 volt. Here 1K, and this is 10 volt. So both इनका ऑपरेशन रीजन बताना है. ऑपरेशन रीजन बताने के लिए आपको क्या करना है? IC चेक करना है. If IC is less than IC saturation, then operation region is active. If IC is greater than IC saturation, then operation region is saturation. Here beta is your 10, here beta is 100, here beta is 10. और VBE के बारे में क्या बोला है बताओ क्वेश्चन में? ओके, VBE तुम्हारी चॉइस है, तुम 0 से करो या फिर 0.7 से करो. ओके, सो यू हैव टू फाइंड. सो 10.7 दे रखा है तो 0.7 ले लो, सिंपल कैलकुलेशन हो जाएगा 0.7 से. ओके, so you have to find the IC in this circuit and IC in this circuit. IC saturation, always remember IC saturation is the voltage. In order to get IC saturation, you have to put VCE 0. Just now I plot a graph, VCE and IC saturation, IC. So if you want IC saturation, you have to put VCE 0 in the equation, outer equation. So you calculate IC saturation and IC. In order to calculate IC, you calculate IB and multiply with beta, and directly I calculate IC saturation from this curve and compare and tell me कौन सा एक्टिव में है, कौन सा सैचुरेशन में है, कौन सा सर्किट. And this will tell me, Shekhar will tell me, Shekhar and Somajit. First find out IB, IC saturation. Same here, IB, then IC saturation. Compare IC. Okay, so you have to find here IB. IB is nothing. VCC, this circuit 10.7 minus 0.7. Okay, VB divided by 10 kilo ohm. So this is 10 upon 10 into 10 raised to power 3. That is 1 milliampere. It is very high current. Always IB comes microampere. It is coming milliampere. So you always always get doubt that circuit can go in saturation. If you calculate IC, that comes out 100 milliampere. And if you calculate IC,
saturation region,
so if you calculate IC saturation, इस ग्राफ में IC saturation कितने निकालेंगे? VC 0. That means your IC saturation will be VCC upon only RC, और कुछ है ही नहीं यहाँ पर. So 10 VCC is 10 volt, and this is your 2 kilo ohm. That is 5 milliampere coming. So IC is much larger than IC saturation. Okay, so this circuit will go to the saturation. This circuit is in saturation. And what is the operating point? That is important. Operating point क्या होगा बताओ? Operating point of this circuit will be VC 0 and IC this 5 milliampere. This is the operating point of first circuit. Because current जो भी निकल रहा है ये पॉसिबल नहीं है. मैक्सिमम करंट यही पॉसिबल है सर्किट में. दिस इज द मैक्सिमम पॉसिबल करंट, and with respect to this your VC is 0. So this is the operating point. Now find out for second. Now let us find for second. For second, what will happen? Again, you have to find IB. IB क्या आएगा? ये 5, this minus 0.7 upon 10 kilo ohm. That is 4.3, 10 raised to power 4. That is 0.43 milliampere. Okay, 0.43 milliampere. Now your IC will be 4.3.
active region में ऐसा set.
ये 4.3 milliampere हो गया IC, multiply by 10 this one. Okay, and you find the IC saturation. IC saturation will be here 10 upon 1. VCC, this is 0, 10, 1 kilo ohm. That is 10 milliampere. So in this question, your IC is less than IC saturation. So this is the operation region is active. And operating point क्या होगा बताओ? Operating point निकाल लो. Operating point निकालने के लिए IC आपको मिल ही गया. IC is your कितना? 4.3 milliampere. So operating point will be your VCE will be VCC 10 minus RE यहाँ पे है ही नहीं. जो यहाँ पे VC आएगा वही VCE है. ICRC, IC कितना है आपका? 4.3 milliampere. ये 1 kilo ohm. ओके, 10 4.3 कितना आएगा बताओ? 6.7 5.7 volt. So operating point this one is 5.7 dot 4.3 milliampere. 5.7 volt and 4.3 milliampere. तो आपको जैम में तो क्वेश्चन बहुत आसान आते हैं, चाहे ये हो, चाहे ओपैम्प हो, चाहे डिजिटल हो. ओके, बस आपको रिवीजन करा हुआ होना चाहिए. अगर आप करोगे नहीं तो फिर आपको हर चीज टफ लगेगी. वो करा हुआ है तो सारे सब्जेक्ट आपके तो आसान ही है, तो कोई भी कॉम्प्लिकेटेड क्वेश्चन आता नहीं है। ओके, बस आपका कैलकुलेशन ठीक होना चाहिए, आपका कंसेप्ट ठीक होना चाहिए, एंड यू शुड डू द कैलकुलेशन इन प्रॉपर मैनर. So this is your now last question. Okay, last question, कौन सा सर्किट है बताओ? टू ट्रांजिस्टर्स आर कनेक्ट बेस टू ये बेस, इसको क्या बोलते हैं? रिवीजन कर ही नहीं रहे, उसका मतलब अगर दो ट्रांजिस्टर ऐसे कनेक्टेड हैं तो उनको क्या बोलते हैं? डार्लिंगटन पेयर. ओके, सो क्वेश्चन में 10 वोल्ट दे रखा है, दिस इज गिवन 5 वोल्ट. ओके, दिस इज 100. तो क्वेश्चन में पूछा क्या है? द बेस करंट इन द फर्स्ट ट्रांजिस्टर ऑफ द फॉलोइंग सर्किट हैविंग टू एंटी सिनुइकल बेस एंड ट्रांजिस्टर बीटा वैल्यू इज 100. ओके, बेस करंट पूछा है आपको, IB पूछा है. व्हाट इज दिस IB? सिलिकॉन बेस्ड ट्रांजिस्टर है एंड बीटा वैल्यू इज गिवन 100 फॉर बोथ. बीटा 100, बीटा 100. ओके, सिंपल क्वेश्चन है भाई. आपको क्या होता है कि इसका जो IE है वो कितना होगा? इफ यू नो दिस IB, सपोज दिस इज IB, तो दिस इज ऑटोमेटिकली बीटा प्लस 1 IB. अब ये इसका बेस करंट बन गया, इसका अमीटर करंट इसका बेस करंट बन गया. तो यहाँ का अमीटर करंट क्या होगा? यहाँ का अमीटर करंट होगा बीटा प्लस 1 इंटू बीटा प्लस 1 दिस IB. ओके, नाउ इफ यू वांट टू, क्वेश्चन में क्या पूछा है? बेस करंट पूछा है. बेस करंट निकालना आसान है, ये 5 वोल्ट है. सो दिस 5 वोल्ट ड्रॉप कहाँ हो रहा है? यहाँ हो रहा है, यहाँ हो रहा है, 0.7 हो रहा है, -0.7 हो रहा है. उसके बाद में कहाँ हो रहा है? यहाँ पर हो रहा है वोल्टेज ड्रॉप. कितना हो रहा है? IB इंटू दिस 100 RE okay, into beta plus 1 that is 101. Okay, into 101, or you can write beta square also. So basically I want now my IB that should be equal to 5 minus 1.4. okay, divide by 101 into RE is 100. So basically 10 to the power 6, इसको भी 100 मान लो. तो 5 minus 1.4 कितना आता है? 3.6. 3.6 and 10 to the power 6, 2. तो आंसर 3.6 माइक्रो एम्पियर आ रहा है क्या? चेक करो, 3.6 माइक्रो एम्पियर. So the base connected, it is is the emitter current will be base current for this one, this and this emitter current. So this is the IB, so this will be beta plus 1 IB or beta IB, and this will be what? Beta into beta again this IB, because this is the IB, this IE. So you know this drop, you know total voltage, you know this drop, you can find this one IB, that should be 3 point micro ampere. कितना आ रहा आंसर? चेक करके बताओ. 3.6 माइक्रो एम्पियर दे रखा है, ऑप्शन ए दे रखा है. ऑप्शन ए शुड बी करेक्ट. ओके, so let me check the answer. कितना आंसर है? नहीं, सॉल्व नहीं रखा, सॉल्व सॉल्यूशन में नहीं दे रखा ना, तो ऑप्शन ए ही होगा इसका आंसर.
यही आएगा
हाँ
सर.
सर यही आ रहा है.
ठीक है, चलो ठीक है, तो फिर अभी यहीं स्टॉप करते हैं. कल हम करेंगे अपना ऑपरेशनल एम्पलीफायर के क्वेश्चन बहुत अच्छे हैं. ऑपरेशनल एम्पलीफायर एंड देन विल सॉल्व दिस डिजिटल इलेक्ट्रॉनिक्स टुमारो. ओके, थैंक यू, विल स्टॉप हियर.
Thank you, sir.
थैंक यू सर.